Let's do this problem. And guys, first we read a question. Express sine 3 theta in terms of powers of sine theta. Hence, use Osborne's rule to derive the hyperbolic identity for sine hyperbolic 3 theta. And so guys, I start that question. And this is how I'm going to start it, guys. I will write sine, say we have sine 3 theta. Guys, I can write it in this format. I want to write it this way. According to complex numbers, we shall have cos 3 theta plus j sine cos, that is sine 3 theta, can be written as, according now to the Moivre's theorem, this is now going to be cos theta plus j sine theta cubed. So guys, this is according to the Moivre's theorem. So in other words, guys, what we are saying that if our 3 is, for example, is n, we could have something like this. We usually have cos n theta plus j sine n theta is usually given by cos theta plus j sine theta raised to n. That is according to the Moivre's theorem. And so therefore, guys, now we are going to expand this term. And for us to expand that, guys, we are going to use the Pascal's triangle. That is, this is the Pascal's triangle for that. So this is the triangle, guys, we are going to use according to binomial theorem. So guys, we are going to expand this using this Pascal triangle. And this is now going to be equal to, first of all, right here, cos 3 theta plus j sine 3 theta. This is equals now, we expand that. The first term is going to be cos cubed theta plus, you have 3 cos, now is going to be squared theta. And then we also have to have a j sine theta plus the third term, we have 3 cos theta, now it's going to be cos theta, and then j is going to be squared, the same with sine squared theta. And finally we have j cubed sine cubed theta, like that. So guys, this is what we are now going to have. Maybe you can leave this one aside a bit and write what we have here. We have cos cubed theta plus 3 cos squared theta j sine theta plus 3 cos theta j squared sine squared theta plus j cubed sine cubed theta. So guys, after we have arrived at that point, we are now going to convert, because we know, guys, that j squared is supposed to be given by -1. We are going to replace that with -1. And so therefore, guys, we are going to have cos, we have cos 3, that is cubed theta, plus, here we have 3 cos squared theta j sine theta. And then, guys, when we come now to j squared, this one now is we are going to remove the j squared and change the sign. So it will have minus 3 cos theta and then sine squared theta, plus, when guys we come here, we have j squared and multiplied by j. That gives us j cubed. And so we are going to have now minus j sine cubed theta, like that. So guys, now we are going to equate our equation on the right side and on the left side. So first, guys, I write the equation on the right side. The right side, I have cos 3 theta plus j sine 3 theta. This is equals to, now guys, I look at my left side, which is this equation. I can write, first of all, I write in terms of, for example, the real numbers. For the real numbers on this side, we have cos cubed theta. Then we have negative 3 cos theta sine squared theta. That is for the real numbers. For the imaginary numbers, I will have plus those that have the j. So I can write, first of all, write j like that, and then I can write a bracket there so that I can write now my imaginary number. This is now going to be 3 cos squared theta sine theta minus sine cubed theta. And so therefore I can now equate my sine. My sine 3 theta should be equal to that. That is for the real, for the imaginary, and this is even for the imaginary. And so therefore, guys, I will have sine 3 theta will now be equal to 3 cos squared theta sine theta minus sine cubed theta, like that. So guys, I can now from there put this one in terms of cos. So this is now going to be sine 3 theta. This should be equal to 3. Instead of putting cos squared theta, I will put it as 1 minus sine squared theta. Then I multiply there by sine theta minus sine cubed theta, like that. So guys, I will have sine 3 theta is equals to 3. Then I multiply 3 multiplied by sine negative sine squared, it will be 3 sine squared. Actually, it's now going to be sine cubed because of this sine theta. And here we are also going to have sine theta. That is 3 sine theta minus sine cubed theta. Guys, this is now going to be sine 3 theta is going now to be equal to 3 sine theta. Then we can add this. If you add this, you get minus 4 sine cubed theta. Guys, now we come to change them into hyperbolic functions. And according to the Osborne's rule, if there is a sign that is, in front of a sign, there is a negative or positive sign. And this sign is an implied product of two signs or product of two signs. Then it goes without saying that the negative sign or the positive sign is going to change. For example, guys, here we have sine squared multiplied by sine, that sine squared theta multiplied by sine theta, so that we can have sine cubed. And so therefore sine, we can now write in terms of hyperbolic. Maybe I can write what we mean guys. According to Osborne's rule, if, that is Osborne's rule, product, or if there is product of two signs or product of implied signs, that is, let's say signs, implied signs, let me write it like that, implied signs, that is, for example, guys, if you have tan squared theta, this one is the same as sine squared theta all over cos squared theta. Then the rule says that the sign in front changes. That is the sign before the implied product of sign or the product of sign. So therefore, guys, we are going to have sine, now sec 3 theta will now be equal to 3 sec theta. Now this is going to be plus, because remember we have two signs here. So this is going to be plus 4 sec theta, that is cubed. So guys, that is what we get as our solution.